Hello, classmates. Today we will learn the shortest path algorithm. In the planning of delivery routes, many problems all can be summarized as route selection problem with a single origin point. The only irritating thing here is it refers to a single delivery task. There is only one loading point and one unloading point. So how do we choose? What about the optimal delivery route for a single pickup point? Let's look at a task. A batch of goods is being delivered from the starting point A to the destination D. Find the shortest delivery route from point A to point D. We can solve this problem using the shortest path algorithm. Starting from the vertex, reach another vertex along the edge of the network graph. In the path, travel the path with the minimum sum of distances. It is called the shortest path. The algorithm used to solve the shortest path problem. It is known as the shortest path method. The basic idea of the shortest path algorithm is to start from the starting point. Find the shortest distance from all points to the starting point. Finally, the shortest distance from the starting point to the endpoint is obtained. The steps of the shortest path algorithm are as follows. 1. Find the solved points adjacent to the unsolved points. For every node found that is closest to the starting point, containing a starting point is called a solved node. The rest are called unresolved nodes. The starting point serves as the first solved node. 2. Find the nodes connected to the solved nodes in 1. The unsolved node with the shortest distance as a candidate point. 3. Find the candidate node with the shortest distance from the starting point as a new solved node. 4. Repeat the above process until the endpoint becomes a solved point. When applying the shortest path method, it is usually represented by a combination of numbers and letters. Taking 10A as an example, number 10 represents the cumulative distance from the starting point to this node. 10A represents the sequence number of the previous node of the given line segment. Next, let's take the import task as an example. Introduce the problem-solving process of the shortest path algorithm. From starting point A, start giving point A. The label is 0A. Give the unsolved node B that can be reached from point A, labeled as 2A. The point F is labeled as 5A. Upon comparing the two nodes B2A and F5A, it is found that the shortest path is between A and B, that is, the shortest one is 2. Change point B to a solved node. Starting from B, assign a point to the unknown node C that can be reached from B, labeled as 5B. The label is 6B. The label is 4B. Upon comparing the labels of node C, G, and F, it is found that the shortest path is from A to B via exchange point F4B to a solution node. It is worth noting that point F was labeled as 5A in the previous step. Since the distance is greater than 5 to 4, it indicates that AF is larger than ABF. Can be directly skipped. Starting from point F, give the unsolved point G that can be reached from point F. The label is 5F. One point is labeled as 7F, the same. The two labels of G retain the smaller distance of 5F. Upon comparing the node labels of C, G, E, and 3, it is found that the shortest path is through A, B, F, and G. Change G5F to a second-order node here. Attention should be paid. The distance between G5F and C5B is 5. Just choose one to become a known node. The choice here is G. Students can also choose point C as the known node. Give it a try. Start from G. Give the unsolved node C that can be reached from point G. The label is 10G due to the 10 to 5 advantage. Negligible, the label D is 11G. Compare all unsolved nodes, the path from point C to point A, then to point B, and finally to point C is the shortest. Become a solved node. Starting from C, assign points to the unsolved points. D that can be reached from C. The item labeled as 12C can be ignored. Compare all unsolved nodes, the minimum path from point A to point B in F1. Once it becomes a solved node, give a little from the beginning. The reachable unsolved node D, the label is 9E. D9E becomes a solved node. The shortest path from A to D is 9. Trace back to the node preceding the labeled one. The shortest path in terms of sequence number is AB. FED. We have learned to utilize the shortest path method, seeking the optimal solution to the unit's shortest path problem. The steps this method involves relatively cumbersome steps. I hope everyone can practice well next. Assign a task to the students for after-class consolidation. Okay, that is all for this lesson. See you next class, classmates.